Anthropic and taught by returning instructor Ellie Sherwick. Skills give Claude Code and other agents new abilities to carry out tasks. I'm thrilled to have Ellie return to teach this.
Thank you, Andrew. I'm happy to be back and work with you all on this one.
Skills are folders of instructions that extend your agent's capabilities with specialized knowledge. In this course, you learn how skills work, learn best practices for creating them, and build skills for different use cases, including coding and research and data analysis and more.
What's exciting about skills is they're now an open standard, which means they have a standardized format that work with any skills-compatible agent. So you can build your skills once and deploy them across multiple agent products.
Any skill should include a skill.md markdown file, which contains the skill's name, description, and main instructions. The main instructions can also refer to other files such as scripts, additional markdown files, and assets such as templates and images. Skills are progressively disclosed to the agent, which means that the skill's name and description always live in your agent's context window, but the agent does not load the rest of the instructions into its context until a user request matches the skill's description. At that point, the agent might then additionally load the reference and asset files if needed as well. To use the skill, your agent needs a basic set of tools: file system access to read and write files, and a bash tool to execute code. And these tools enable your agent to execute whatever commands a skill requires.
Your agent can combine skills with MCP and sub-agents to create powerful agentic workflows. For example, it can use MCP to get data from external sources, then rely on a skill to know what to do with that data or how to retrieve it efficiently. It can also delegate tasks to a sub-agent with isolated context, which can itself use skills for specialized knowledge. In this course, we'll start with Claude AI, where we'll create a skill for a marketing campaign and combine it with the pre-built skills for Excel and PowerPoint. Then we'll create 2 skills for content creation and data analysis workflows and try them with the Claude API. After that, we'll use skills with Claude Code for reviewing and testing code. And finally, we'll build a research agent with the Claude Agent SDK that uses a skill to combine research results.
I'd like to thank Hara Salami from deeplearning.ai who contributed to this course. So, how do you know when to use a skill? Let's say you have a workflow that you repeatedly ask your agent to implement. Instead of explaining the same workflow every time, you can package it as a skill so your agent automatically knows what to do. That's exactly what you learn with Ellie in the first lesson. So please go on to the next video to learn more.
Skills are folders of instructions that package repeated workflows, specialized knowledge, or new capabilities for your agent. If you find yourself typing the same prompt across conversations, you should consider transforming that into a skill. Let's explore how to do that using Claude AI. So before we talk a little bit more about skills and dive into what a skill looks like and how it works, let's walk through a scenario to showcase why skills are so useful. Right here, I've got some campaign data in a CSV that I'd like to analyze the performance of. So just to show you what this looks like, I've got a date, a campaign name, impressions, clicks, conversions. You can imagine here that we're going to take in some marketing data and use Claude to analyze this information. So in my first prompt, I'm attaching this data, explaining what the input data looks like, asking to check for quality, funnel analysis, and some useful metrics around what I expect for click-through rates and conversion rates. At the bottom, I've got an output format that I'm requesting for this particular piece of data. Now you can imagine it would be valuable to not have to include this prompt every time and to have that packaged up. As we take a look at what we're seeing in our campaign data, Claude is going to read this CSV. It's then going to perform the data quality check and funnel analysis and give us back our campaign performance analysis. Here it's going to show the total records, any missing data, and any anomalies in the data that exist. If we take a look a little bit further, we'll see our funnel analysis versus the benchmark data that we were looking for before. We can see here some things that are working better, some things that are not working as well. We're getting a lot of useful data back that we can take action around, change our marketing campaigns, and move forward. We got a nice interpretation of what Claude is telling us, what's working, what's not working. And now we're going to go ahead and ask for additional computations of certain efficiency metrics for marketing. These include return on our ad spend, cost per acquisition, and net profit, and so on. We're also going to ask for an output format in a certain fashion. We'll see the results from this efficiency analysis. We'll see what's working, again, what's not working, and some interpretations. We'll see our portfolio performance and our total net profit. Looks like we're making money here, but there's still much more that I'm sure we can do. The next step that we're going to do here is to take in an additional piece of data, our budget reallocation rules. The idea here is that we have extra money to play around with and think about allocating towards other marketing channels. You can imagine this file has quite a bit of data around the rules for allocating, what we're trying to figure out, and how best to decide where to increase our budget. This could also lead to maintaining a budget or decreasing a budget based on this framework that we have here. Again, this is a lot of data that is specific to our particular use case. Claude knows how to handle particular decisions and analyze marketing metrics, but here we're specifying exactly the way that we want to do things. This requires me bringing in external documentation, finding the right people, and even if I'm not the most knowledgeable about this, hoping that I get it right. We're going to go ahead and see these allocation rules, our recommendations. We can see what's passing, what's not passing, and a proposed reallocation here, freeing up some budget, analyzing what's working, and where to allocate additional budget towards. What we've seen here is a step-by-step process that requires us as the user to put in the necessary documentation and have the necessary pre-existing knowledge. Not only that, but everything that I'm putting in here is immediately getting added to the context window. What happens if I want to ask something different? What happens if I want to have a different kind of conversation? This information here is not always necessary for everything I'm going to do. What we're going to take a look at here is how we can take this information and package it into a skill, a standalone asset, a folder really, that contains instructions for how to go about performing the campaign analysis while also being intentional about what information goes into the context window and what information doesn't. As we've seen, this is a weekly campaign performance analysis. So this isn't something that I want to have to repeat on my own every single week with this particular prompt by copying and pasting. This is going to be much nicer to have prepackaged that I can use myself, share with members of the team, and edit as necessary. So with that, let's take a look at what a skill.md file is. This file needs to be named skill.md in Markdown format, and this is going to be the underlying set of instructions to perform the task that we saw. In this Markdown file, I have very similar information to what I included in the previous prompt. I have my input requirements, a data quality check, funnel analysis with the metrics that we were working at before, and historical benchmarks. I have that same efficiency analysis as well as the output format that I expect. Finally, I have a note here on budget reallocation that references a different file only when the user asks about budget reallocation. So we talked a little bit about how this can be much more efficient with context. This is one example where I'm only going to be reading and using this file if a user asks about that particular piece of information. In order to get this skill to work as expected, there's one more piece of data that I need to add to the beginning here. This data is in a data format called YAML, and here's what it looks like. Every skill that you make across the entire standard requires a name as well as a description. The name of the skill is going to be important for referencing when to use it and in the UI that we're working with if it's being used. And the description is important so that the model that we're working with can understand when to use this particular skill. When you make a skill, the name and description are required. So we've got our skill MD file, and the second file I want to show you is just this budget reallocation rules file, which is very similar to the other prompt that we saw. When you make a skill, your skill can reference other files as long as they're all in the same parent folder. These budget reallocation rules are exactly what I put in that previous conversation with Claude AI. So what we're doing here is we're moving away from putting in instructions directly in our conversation and instead putting it into a folder. Now that I've got this skill file as well as any external files, what I'm going to do here is make a new folder. And I'll name that folder the name of the skill, Analyzing Marketing Campaign. There are some high-level rules around naming skills. Stick with lowercase letters, use dashes between words, and don't use reserved keywords like Claude or Anthropic. Now that I've created this folder for the skill that I'm making, I'm going to go ahead and make another folder called References. When we look at the open standard for skills, we're going to see that this actually is a specific name that we use when there are external references that the skill uses. And inside of our skill MD, we linked to references/budget reallocation rules. So I'll go ahead and put that file in this folder. I'll put the folder inside of our marketing campaign, and then I'll put the skill MD at the top level of this folder. If we take a quick look at what's inside, we should see our skill MD as well as our references folder that contains that additional budget allocation file. Now I'm going to go ahead and create a zip file from this folder, and I'm going to go ahead and upload that to Claude AI. Once I upload that skill, I should be able to start using it in future conversations. I'm going to head over to my settings right over here, and I'm going to go to capabilities. As I navigate to the bottom of capabilities, we're going to see this section on skills. There are some example ones that we'll talk a little bit about later, but right now I want to add my own. So I'm going to go ahead and add, and I'm going to upload the skill in a zip file that I created. I'm going to go ahead and drag and drop that zip file and give that a second to upload. Once that's done, we can see the name of our skill as well as that description. Now that we've uploaded our skill, let's go see this in action. I'm going to start with a new chat. I'm going to go ahead and ask Claude a similar prompt to what I had before, and I'm going to go ahead now and attach the same CSV that I was working with before. If this works as expected, we should start to see Claude pick up the skill for our weekly marketing campaign. Claude should then perform the tasks required in that skill, and the need for us to have all that prompt back and forth is no longer there. So let's go ahead and see what Claude can do here. We'll see here it's going to read the skill file to ensure it's following the right instructions. The name of our skill as well as the description is what is allowing Claude to pick this up. Since we're asking about reallocating the budget, it's going to go ahead and read that additional file that we uploaded to our skill. We'll then go ahead and analyze the data. If we want to see the code that Claude is running and executing here, we can always open this up and take a look at what's happening behind the scenes. What we're going to see here is something very similar to what we saw before. We're going to analyze channels that may have additional challenges, in this case, TikTok. We may see things that are working as well as recommended reallocations. But in this case, we didn't have to add all of the prompting ourselves. This skill can be shared across many different platforms, and since skills are an open standard, this is supported in other coding environments like Codex, Gemini CLI, and much more. So not only have we created a way to take this data and package it up into a centralized place, we're being more efficient with a context window, and the portability here is extremely valuable. Now, let's go ahead and create a report with the data that we found. We're going to go ahead and create an Excel report with the following pieces of information, as well as a color coding that we're recommending. Under the hood, the ability to create spreadsheets and execute necessary code to do so actually lives in a skill that comes built in to Claude. So we're actually going to see the underlying skill being used, code being run to create this Excel file, and then finally the output based on the requirements that we specified. We've got our spreadsheet now. Here we can see we've got an executive summary, funnel analysis, efficiency analysis, and we can go and open this in Google Drive or download this spreadsheet. Through the use of our skill to analyze data and give us what we need, as well as built-in skills to create spreadsheets, we can transform data from CSVs into meaningful, actionable insights in many different kinds of file formats. Next, we'll explore in a little bit more depth what a skill looks like, how it works, and where it fits into the entire AI ecosystem. In the previous lesson, we saw how to create skills in Claude and move from prompts with data to package skills that we can use across many different conversations. Now let's dive deeper and talk about what skills are and the open standard that powers them. Similar to the Model Context Protocol, skills themselves are an open standard that can be used across many different AI applications. While skills were something originally created at Anthropic, skills themselves are now an open standard with a specific specification that is used across many different platforms, including Codex, Gemini CLI, Claude Code, Open Code, and much more. With that in mind, let's talk a little bit about how this works. When we build AI applications, in order to use particular skills, we need to make use of some kind of file system when using tools like Claude AI or Claude Desktop. In that file system, we load folders that contain a skill MD file and subfolders or files that can be referenced. Here we can see exactly what we did previously. At the same time, Skills themselves can not only include other markdown documents, but scripts that can be executed. For example, we have a skill for working with PDF documents. We need to convert PDFs to images, extract info from form fields, and even fill PDF forms with annotations. This requires code to be executed, but that code that needs to be executed can be referenced from the skill MD file. So as we start to explore our own custom skills and built-in skills, it's important to note that skills are not just text files that reference other text files, but text files that can reference scripts, what they do, and when they need to be executed. Skills can also include icons, images, and other assets as we start to think about ways of creating custom styles and brands. Where skills really shine are places where Claude might not know exactly how you or your company operates. You can imagine designing newsletters, creating brand guides, things that Claude has a general idea on, but not the exact way that your company or your team does it. To give some more idea of why we bring agent skills into the mix when we're building our own agents, the way that we used to think about building agents centered around agents with a single purpose: coding, research, finance, marketing, and much more. These domain-specific agents had a particular set of tools, the context it needed to perform the task necessary. But as we started to build more of these single-purpose agents, we started to realize that under the hood, all that they really need is a simple scaffolding. Underlying tools like Bash and a file system to find, edit, modify, execute, and perform whatever tasks are necessary. These simpler agents are easier to evaluate, understand, and scale. But what these agents lacked was the underlying context and domain expertise to do the job reliably. That context can be provided through skills, through the Model Context Protocol, but that domain expertise is really where skills shine as well. We want finance agents to perform financial analysis in a particular fashion. We want research agents to have the domain expertise necessary to research the way that we want. We want to be able to port that across many different ecosystems and agents, and that's why we have agent skills. These skills provide us the procedural knowledge and the user-specific context that they can load on demand. In addition to domain expertise, skills can also provide a repeatable workflow. In a non-deterministic system, where we don't always know exactly what the output of the model is going to be, it can be difficult to find repeatable ways of producing the same output. What skills allow us to do is provide a repeatable workflow with very articulate steps or instructions that allow the agent to perform a task that we can start to predict with more accuracy. Skills also introduce the idea of new capabilities, things that an agent does not know how to do out of the box, or even data that Claude has no idea how to operate on. When we bring in these new capabilities, we unleash an entire ecosystem and new functionality for our agents with minimal additional context. As we think about domain expertise, we want to lean on things that Claude might not know how to do or knows how to do, but not for your particular domain. Claude can perform data analysis. Claude can perform legal review. But how does it do it the way that you or your team or company want it to be done? We previously saw the ability to perform weekly marketing campaign reviews, and we want that to be predictable across many different individuals and teams. As we start to think about some of these new capabilities, things like generating presentations, Excel spreadsheets, PDF reports, executing scripts when necessary to perform those actions, that here is where agent skills can shine. What we saw previously without skills was the idea of describing our instructions, trying to predict workflows, and bundling all of the necessary files in context at one time. We talked a little bit about the portability of skills. And while we've seen skills so far in Claude AI, skills can be used in the exact same format, not only across Claude Code, the Agent SDK, and the API, but since agent skills are an open standard, you can use this across a growing number of agent products. You can create skills in one environment and use them and share them and scale them across many different environments. When we say that skills are composable, this is something that we've seen already. We can take custom skills like analyzing our marketing campaign, and we can combine that with built-in skills like creating PowerPoint presentations, PDFs, or Excel spreadsheets. Not only can we use multiple skills together, but we can combine them to build complex and predictable workflows. We can reference the skills necessary, the steps necessary, and start to create predictable outputs in a non-deterministic system. Under the hood, skills can contain quite a bit of information. We saw examples with additional markdown files and even examples with scripts that can be executed. You can have hundreds of skills across your system, and what we're going to see quite a bit more is that to protect the context window, skills are progressively disclosed. The idea of progressive disclosure is to only load the data necessary and avoid polluting the context. We like to think of the context window as a public good. The more data that we add to the context window, the more tokens we consume, the faster our context window fills up, and the likelihood of context degradation or incorrect responses potentially increases. In order to avoid polluting the context window with data that we might not need, skills introduce the idea of progressive disclosure. When skills are loaded from the file system, the only data that gets added to the context window is the name and description of the skill. This is essential so that Claude or any other system knows what the skill is and how to trigger it. Once that skill is triggered, the underlying skill MD is loaded. This is the next phase of loading data into context. And depending on what is required, if there are additional files or scripts that need to be loaded and executed, those will be loaded progressively. These additional resources can be loaded as needed. And if there are scripts that need to be loaded, those scripts are loaded and executed separately from the context window to avoid polluting with additional tokens that are not necessary. By using tools like Bash and a file system, Claude can load only the information that's necessary, execute only scripts and reading of files that is necessary, and intentionally only add what is necessary to the context window. In the next lesson, we'll continue talking about skills and particularly how they're used alongside other technologies like the Model Context Protocol, subagents, underlying tools, and much more. In the first lesson, Claude AI used the Excel skill to create spreadsheets displaying the marketing results. The Excel skill is one of Anthropic's pre-built skills, which also include a PowerPoint, Word, and PDF skill, as well as a skill creation skill. Let's take a look at those. Now that we've seen how skills fit in the entire AI ecosystem, let's take a look at some of the pre-built skills that you can use out of the box with Claude AI and Claude Desktop, and that you can install yourself with tools like Claude Code. Inside of this repository that lives at github.com/anthropic/skills, let's take a look at the skills folder and see which built-in ones that we have. All of these are ready for production usage, and we actually saw in a previous lesson the use case of this Excel skill. It's important to note that this list of skills, while created at Anthropic, is actually bucketed into two different sections. The skills for Microsoft Docs, PDFs, PowerPoints, and Excel are known as document skills. These are built in and always used in tools like Claude AI. The remainder of these skills are examples that we've created that you can toggle on and off in Claude, but by default, with the exception of Skill Creator, are toggled off. Let's first start by analyzing the PowerPoint skill. We can see, just like other structures, that we have a skill MD file, as well as other files and folders to reference. Inside of this skill MD, we have that same YAML front matter that includes the name and the description. What you're seeing here is how GitHub is rendering this markdown file, but the underlying code looks very similar to what we've made before. You can view it this way if you're familiar with markdown files. I'll switch back to the preview because it looks a little bit nicer. When we take a look at how this skill works and what it does, we've got an overview. The users may ask to create, edit, analyze contents of a PowerPoint file. Here's what it looks like. Here's how you read it. And if there are particular tasks that need to be done, there are underlying scripts to go ahead and execute. Remember, these are not executed right out of the box. These are only loaded and executed when necessary. There's quite a bit that we can do with PowerPoint presentations, colors, typography. As you can imagine, this is how we can start to make things that look nicer and look more like real-world presentations out of the box. There are design principles that we have, requirements that are necessary, and color palette selections that we can have Claude pick from when the user does not specify them. This skill MD is quite long, as there's quite a bit that we can do with PowerPoint presentations. But what we're going to see later in this lesson is how to actually use this skill to take existing data and turn it into a beautiful looking presentation. The next skill I want to show you is a little bit of a meta idea here, and that's called the skill creator. And the skill creator is a skill that serves the purpose of programmatically creating skills for you. Instead of having to do things from scratch and create the necessary files and folder structure, the skill creator can do that for you. Let's take a look at the skill MD file and see what's happening here. Similar to our other skills, we have a name and a description, and I'm actually going to take a look at the underlying code here since it's a little bit easier to follow. We specify in this skill MD file what a skill is, what it provides, and then we include some of the best practices associated with skills. We're going to dive into those best practices in the next lesson, but you can imagine when Claude is programmatically creating skills for you, we want to leverage some of these best practices. When we take a look at the skill creation process, we're extremely explicit with the steps that we have here. Since we want to use this skill to create a predictable workflow, we want to be extremely explicit with what the steps are, how to follow them, and what to skip only if some reason exists. We start with concrete examples, we plan reusable skill contents, and here you can start to see examples that are very helpful for Claude to pattern match when there's a skill you'd like to create. When we start initializing the skill, here we're running underlying Python scripts to perform the task necessary. Let's take a look at what those scripts do. Inside of the scripts folder, I have 3 Python files here. A script to initialize the skill and provide the underlying text, a Python file to package that skill, and then a script to validate that skill. Let's take a look at what this underlying code does to initialize a skill. We take an existing template that we have with some YAML front matter and some placeholders and to-dos, and we fill that in based on the data that is coming in. This underlying script allows us to create the necessary text files when making our skills. Once we've generated the necessary files, we can package that up. Here you can see we're bringing in the necessary modules to zip our skill necessary and make sure that we're doing this in the right folder and file structure. Finally, we have one last script to perform a validation of our skill. Make sure that a skill MD exists, validate some of the YAML front matter, and make sure that what we put inside of our folder and files is correct. We're going to be leveraging this skill creator skill to take existing content that we have and package it up into a reusable and modular script. Now let's go ahead and shift gears back to Claude and see how to put together built-in skills, our own skills, and a predictable workflow with an MCP server. Back in Claude, let's go and take a look and make sure that we have the correct skills enabled and where those live. Back in Settings, inside of Capabilities, we saw previously we can create skills in this section. What I want to show you are the example skills that we have, and this should look pretty familiar. This is what we saw on GitHub. By default, these skills are turned off. If we want to toggle them on, we can absolutely do so. The skill that is toggled on by default is the skill creator that we just saw. It's important to note that while the skill creator is extremely effective at creating underlying skills and structure necessary, we still have to be intentional about the prompt that we provide and the data that goes in to the skill that we're going to make. What we're going to do now is put all of these ideas around skills, MCP, and prompting together. First, we're going to modify our previous skill that we created for analyzing campaigns to not use a CSV for data, but instead BigQuery. If you're not familiar, BigQuery is a data store powered by Google, and in order to bring in the necessary tooling and context to work with BigQuery, we're going to connect an MCP server. So we're going to use the skill creator skill to modify our previous marketing analyzing skill to use BigQuery. We're then going to use skill creator to create another skill. This will be for the purpose of brand guidelines. We'll include a file that specifies the guidelines as well as logos, and we'll build for ourselves another skill to perform that task. Finally, we'll take our two skills that we used to extract and analyze data and to leverage brand guidelines and combine them with a built-in skill for creating PowerPoint presentations to create a workflow that makes use of prompting, skills, and the model context protocol. Before we jump in, you might be wondering where the Excel and PowerPoint and other document skills that we saw before live. These are built in to Claude AI and are not things that can be toggled on and off. So with that in mind, let's start this workflow. Before we modify our analyzing marketing campaign skill to use BigQuery, let's also make a note that we're using Claude Desktop here to connect to a local MCP server to leverage BigQuery. So let's take a look at how that BigQuery server is configured. I'm going to head over to Settings, Developer, and here we can take a look at the underlying command and arguments and environment variables for the particular project and where my credentials live. For this example, we don't have to use BigQuery. You can use a database, some external data store, but we just want to showcase what it looks like with skills and MCP servers working together. And if you're interested in seeing that underlying config file, here's what it looks like. In this config file, we specify the servers we want to connect to and the underlying commands to run when Claude Desktop starts. With that in mind, let's go ahead and modify our previous skill to now use BigQuery instead of CSVs for data access. To make sure this is working correctly, let's first ask Claude to list the tables in BigQuery that exist. This is going to make use of the MCP server that we have. We're going to allow this, and we should get back the list of tables. In this case, we only have one. So here we can see there's a data set called marketing that contains a single table. Now we're going to ask Claude to show me the schema of the table. Hopefully Claude can pick up that small spelling mistake, and we should be in business. Here we're specifying what the table looks like, and this looks great. And we're going to make use of this schema when we go ahead and update our analyzing marketing campaign skill. What we're going to do now is ask Claude to update our analyzing marketing campaign skill so that instead of a CSV upload, we pull from BigQuery. We specify the data from the BigQuery table, specifically the schema that we just saw above. Since we're all in one single conversation, Claude should have no problem taking a look at what the schema is. We're specifying some requirements for this, and just like in our existing skill, we want to make sure that the reference to our budget reallocation rules does not get modified. Like we spoke about earlier, the skill creator skill is extremely helpful and efficient, but we still need to give the context necessary. Notice here, the first thing it's going to do is analyze the necessary skill structure and use our skill creator skill to modify the existing skill and follow best practices. We're going to go ahead now and create the updated skill with a new skill MD file. Here we can start to see something that feels similar to our previous skill, but instead adding BigQuery instead of CSV uploads. Under the hood, we're using the file system and bash tools to create the necessary file and folder structure for us. What we can see here is instead of using a CSV, we're using BigQuery, and we're following the best practice of using MCP servers with skills where we specify the server and the name of the tool. The skill creator is following best practices to take our existing skill and modify it. So as we instructed skill creator, when we specified our required input, we're seeing this in practice right now. It's best practice not to use an ambiguous date range or the entire range, so we ask the user to clarify, and when we show an example of querying, we're specifying a date range. So some of the tools and requirements that we put in are being directly applied when we update this skill. So our skill looks like it's in great shape. In order to make sure this is saved to subsequent conversations, let's go ahead and copy this skill. Now we're going to shift gears and create a new skill for brand guidelines that we'll use alongside this skill to create a compelling, data-driven PowerPoint presentation. So let's go ahead and start with a new chat, and we're going to ask Claude to create a brand guidelines skill from files that we upload. The first thing I'm going to do is upload a file with my brand guidelines, as well as some logos to be used in the presentation. Before we go ahead and create this skill, let me just show you what these brand guidelines look like. I've got a color palette, supporting colors, typography. Claude knows how to design things, but where skills really shine are where you can tell Claude exactly how you want things done for your company. Logos, colors, fonts, great example. Now let's go ahead and create a skill from these files that we can apply to future presentations and documents. What we're going to see here is the skill creator skill in action again. We're leveraging the existing tooling and skills that we have to use best practices, as well as the guideline and logos to make a skill that is repeatable and portable. We're going to analyze other existing skills to see what patterns they use and make sure that this new skill we're creating can complement them. And this is extremely valuable since we're going to be using this with PowerPoint presentations. Now that we have a good idea of what needs to be done, let's run that init skill Python script that we saw before. This will create the underlying skill, and now we can start adding our assets to the skills assets folder. We're going to start to see colors populate, accent colors, fonts, typography, and in a bit, we'll have a skill that we can start adding to all future conversations when there's design that we need done. Our logos are being pulled in, Word documents and PDFs are specified, and presentation layouts are the way that we want them to be. The skill creator has finished running, and here we have a skill MD file that's been created, following best practices with a name and a description, as well as underlying folders with the necessary data and logos that we need. There's one more step we need to do to make sure that this gets added to future conversations. In order to make sure this is saved to subsequent conversations, let's go ahead and copy this skill. Once this is done, we should see this skill in the list of skills that we've created. Now that we've updated our skill to move from CSVs to BigQuery and created a new skill for our brand guidelines, let's combine that to build a workflow alongside the built-in PowerPoint presentation skill to first analyze our data and then generate a presentation. So we're going to first analyze our marketing data for a different week in BigQuery to see how each channel is doing, and then based on that data, generate a presentation with our brand guidelines. Let's see what this looks like. First, we're going to go ahead and read the relevant skill files. This includes our marketing campaign analysis, and will include our BigQuery guidelines as well. We're going to go ahead and make sure we have the correct PowerPoint presentation skill, as well as our brand skill for styling. Inside of the underlying PowerPoint presentation skill, there's additional documentation for presentation creation. First, we're going to go ahead and start with BigQuery. We're going to query what's necessary. We can take a look and see the underlying SQL that's being written, and like we saw before, that date range that we're looking for. Now that we have the data, we're going to use these metrics to go ahead and generate a PowerPoint presentation. We're going to do so with the styling that we've advised in our brand style and turn this into a PowerPoint presentation. You can see here the underlying CSS and HTML being written for our slides, and then we're going to lean into the built-in skill for creating the underlying presentation. Now that we've got the right HTML files, let's go ahead and create our presentation. Here we're using the native PowerPoint skill and writing the necessary code to create the presentation. We can see here, even when there are particular issues, the model will go back, edit anything necessary, and lean on the exact workflow, not only for running code necessary, but validating what needs to be done. This ability that the model has to backtrack and follow particular patterns allows for us to create presentations that don't come with built-in issues that we need to immediately then correct. So we're seeing that Claude's done its verification, the slides look great. Now it's going to go ahead and generate that underlying PowerPoint presentation, which I can open up in Google Drive and use as Google Slides, or I can download directly. We can see here, I've got some really nice looking slides with the colors, fonts, logos, and everything that I want for my particular company. We have our efficiency analysis, funnel analysis, and the executive summary that highlights what needs review and what's doing quite well. I can download this presentation, I can continue to build off of it, and again, open it up in Google Drive to share with teammates. I can continue prompting and working with this presentation, but what we're seeing here is an underlying PowerPoint presentation created from a built-in skill combined with two skills that we've made alongside an MCP server pulling in data from BigQuery. In the next lesson, we'll explore some of the best practices around creating skills and take a look at two other custom skills that we create and see if we're following the best practices. You can combine skills with tools, MCP, and subagents to create powerful agentic workflows. Let's go through each component, see how they work together, and learn when to use what. I'll see you there. In this lesson, we're going to explore how skills fit in to the agent ecosystem. With so many different technologies like MCP, skills, tools, and subagents, let's make sure we understand how they all work together. In your existing applications, we can bring in MCP servers for the context that we need, leverage subagents for their own main thread and parallelization, and bring in skills for those repeatable workflows. Let's see this in a little more depth. When we compare skills with the Model Context Protocol, we want to think a lot about working with external data systems and bringing in the tools and resources that we need. The Model Context Protocol connects our agent or AI applications with external systems and data. That could be an external database, data from Google Drive, using a various array of systems. But anytime that you need external data and context that the model doesn't know about, the Model Context Protocol is extremely helpful. The skills that you have can leverage those underlying tools and data from the Model Context Protocol to teach your agent what to do with that data. Think of the Model Context Protocol as bringing in all of the underlying tooling that we need, and the skill as the set of instructions to put those tools together to build particular workflows that are repeatable and produce the kind of data that you want. As we think about leveraging external data to compute metrics and research and calculate data, all of those underlying tools can be provided externally through the Model Context Protocol. When we think a little bit about skills versus tools, I like to draw the analogy of tools as a little bit more lower level. You can imagine that you have tools like a hammer and a saw and some nails, and you have a skill like how to build a bookshelf. The tools themselves are underlying ways of accessing systems and providing agents with the capabilities they need to accomplish a task. In fact, tools are used under the hood to power the ability to generate skills, to read skills, and even to produce a file system for executing code and loading these skills. Skills extend to capabilities with specialized knowledge, bringing in additional files and scripts that need to be executed. But the ability to execute those underlying scripts and load those files and folders is provided by tools. There are tools that are built in to certain agentic ecosystems. There are tools that we can write on our own, and tools that we can load through the Model Context Protocol. Tool definitions always live in the context window, whereas skills are progressively loaded when necessary. When we think about how these work together, skills allow us to create predictable workflows, and those skills can bring in scripts that can be executed kind of like a tool on demand. If there is a tool that we do not need in every single conversation, we can use that only when needed through skills and progressive disclosure. When we think about how subagents fit into the mix, let's first define what we think of as a subagent. We have a main agent that can spawn or create subagents that can report back to the parent agent. These subagents can be created through ecosystems like Claude Code or the Agent SDK, or we can also make our own. When we think of the value that subagents provide, we think a lot about having an isolated context with fine-grained permissions, as well as executing tasks in parallel. When we think about what these subagents can access, we have limited tool permissions, and we also can specify what skills each subagent can access. So while the main agent can serve as an orchestrator and can leverage whatever skills necessary, subagents can do the same type of idea with making use of particular skills. Subagents work quite nicely with skills, where we can have a particular subagent like a code reviewer, whose sole task is to analyze and review a code base and leverages skills which specify exactly how you, your team, or your company might perform a code review. When we put this all together, we can provide an analogy of a customer insight analyzer. Let's think about how this all works together. We have a main agent that is given a set of tools. Those tools could be provided from MCP servers. We can bring in the data, the resources, the tools necessary to perform the tasks needed. For dispatching subagents to analyze customers, we might analyze interviews from customers or surveys from customers, and do those in isolation and parallelize them to get data back even faster. When we think about how to actually analyze insights from customers, how to categorize feedback, summarize findings, how to analyze interviews and surveys, and how to make sure we do those in a predictable fashion with the right tools loaded at the right time, that's where skills come into play. We bring in data externally, we leverage subagents if we need to parallelize and execute in a separate thread and context window, and we bring in skills to consume all of this information in a predictable, repeatable, and portable fashion. To summarize this, there are many different pieces in the AI ecosystem when we think about building AI applications. Fundamentally, we have prompts, the underlying most atomic unit in a conversation. Prompts are the underlying tool for us to communicate with models, but prompts themselves don't scale very well across teams and companies. To bundle these underlying prompts and conversations and code and assets, we can leverage skills. Subagents that we have tasks delegated to can make use of skills. Those subagents can then consume tools necessary from a main agent that are defined through the model context protocol. As we think about what these particular features aim to solve, we want to be really intentional about how we're loading this information and what this is best used for. When we think about the context window as a public good, we want to be intentional about when subagents can help us minimize what goes in the main context window and how MCP can load the data necessary and skills can load it progressively. When we talk a little bit about the persistence and how we can think about drawing things into a longer-term memory, with subagents, we can persist across many different sessions from the subagent and the parent agent. With skills, we can persist across conversations that we have with the user and the AI application. So as we think about where each of these steps are used, we want to use skills for procedural, predictable workflows and subagents for full agentic logic only when necessary for specialized tasks. In the next lesson, we'll take a look at some of the pre-built skills that come with Claude. We'll take a look at the repository for these skills, dive deep into some of the skill MD files, and talk about a very useful skill called the skill creator, so that we don't have to manually create all of our skills from scratch. In the first lesson, you saw how skills work with Claude AI. Now we'll work with the Claude API to test the two skills we made from the previous lesson. To use skills with the Claude API, we'll need to use the code execution tool and the files API. This will equip Claude with file system access for reading and writing files, and with Bash for executing code. Let's get to it. We've talked quite a bit about how skills work and how to create them, and we talked a little bit as well about the portability of skills across different environments in the Claude ecosystem, as well as many other agentic applications. We started by looking at skills in Claude AI and Claude Desktop, and now we're going to move to talk about how to use skills using the Claude Messages API. There are two things that are important to note. First, skills that you create in Claude AI and Claude Desktop are not shared in the Claude API or Claude Code. The second important piece is that in order for skills to work, we need the ability for Claude to execute code, create and edit documents, presentations, PDFs, and data reports, and work with a file system. This is something that we're going to have to manually do when we work with the Claude API. And this is something that is actually configured for you right away when using Claude AI and Claude Desktop. In Claude Desktop or Claude AI, if I go to Settings and I take a look at the capabilities, you can see here that there's a section for code execution and file creation. This is what we're going to talk about in more depth when we work with the API directly. But this is a setting that is enabled by default that allows Claude to execute code, create docs, spreadsheets, presentations, and more. This essentially gives Claude AI and Claude Desktop a computer or a virtual machine to execute code and perform all those tasks that make skills happen. If this is disabled, we will actually see that we need to turn this on to even be able to use skills. Now let's shift back and talk a little bit about how this code execution tool and file creation works, because we're going to need to enable this manually when we work with the API. When working with tools like Claude Code and the Claude agent, you have direct access to a file system, whereas using the Claude API, we do not and need a container to execute code and a file system to work with. With Claude AI and Claude Desktop, that containerized environment and file system is given to you and not something you have to implement. At the end of the day, the functionality is all the same, but the way in which we utilize skills is slightly different. The skills themselves do not change, the format of those skills do not change, but depending on the environment that you're in, you may utilize the way in which skills work slightly differently. As we start to explore the Messages API, we're going to use the code execution tool. The code execution tool allows Claude to run bash or shell commands to perform all these actions that we saw when working with skills, creating, viewing, editing files, and writing code, all in a sandbox environment. The code execution tool gives our application the ability to have a separate dedicated container to execute code and work with a file system. As you've seen with all the things that skills can do, that is mission critical for reading our skills, executing code within those skills, and working with other files that we might want to edit and view and create. To give you a visualization of what this looks like, when we include the code execution tool, we give Claude an execution sandbox or a container. When we ask Claude to create and execute files, these are executed in a safe and isolated environment. There are limitations for the RAM, the disk, the CPU, and more importantly, there is no internet connection provided, and there are pre-installed libraries that you get out of the box. So this does not work with every single kind of coding environment. There are some limitations here to be mindful of. At the same time, we also get access to a file system that we can start adding directories to. You might have even seen hints of that when we worked with Claude Desktop and Claude AI. This limitation of no internet connection is something that is specific to the Messages API. When we're using the code execution tool in Claude AI or Claude Desktop, we do have access to an internet connection and we can download and install packages. The code execution tool works quite nicely with another set of APIs that Claude API allows us to work with. As you can imagine, when we're working with files, adding, creating, writing, modifying files, we need some mechanism for actually storing those underlying files. The Claude API includes a set of APIs called the Files API to upload and download files that can be run and worked on inside of the container. You can imagine a scenario where the user asks to summarize some input and save the summary to a text file. We upload that input file, send it to the container, download generated files with this Files API. We're going to be seeing this shortly in code when we see the IDs that we get back from uploading and downloading files and how this works nicely with skills and our code execution tool. And this is exactly where skills come into play. The library of skills that we get out of the box in tools like Claude AI, or that we can include if we want using the API, those live in a directory that are powered in the container. As we start to read from this skills directory, as we start to add information to our skills or use those underlying skills to create new files that we can download or upload, this is where skills come into play. And we're going to see a requirement when working with the API. When we want to use skills, we need to use the code execution tool as well. Now that we have a good sense of what the code execution tool and Files API allow us to do, let's see how to use this in action. We're going to go and revisit the two previous custom skills that we built for generating practice questions as well as time series analysis. So let's head over to a Jupyter notebook and explore this. Right here, I have my two custom skills that we've worked with before. I also have a folder for data that I'm going to be using to analyze time series data. I also have a folder for lecture notes that I'll be using when I use my generating practice questions skill. To get started in this notebook, I'm going to load the environment variables that I need, as well as a helper to help me find particular files from a directory. We're going to see this in action when we start using our skills. To start, I'm going to begin using my generating practice questions skill. So let's go ahead and take a look at the first part that I need to do. To begin, I need to upload the skill directory. Here you can see we're using that files from dir helper function, as well as the necessary beta headers for skills. Once this is done, I should be able to see the skill ID that I've created. This betas list are particular headers that I add when I make a request to the messages API. Under the hood, these are turning into request headers to make sure that I'm getting the right data back and communicating appropriately with the API. To take a look at all the skills that I have, I can use this .list method, and I'm going to pass in a source of custom so that we don't load all the built-in skills and instead just confirm that I've created the ones as expected. And here I can see the title as well as the unique skill ID that I'm going to be using shortly. In order for this to work as expected, we're going to need to make use of the LaTeX file where we're going to generate practice questions from. Here, I'll use the Files API to upload this particular LaTeX file, make sure that it's set for reading, and then get back a file object. I'll be using this file object in conjunction with the skills necessary to make sure that it's all working as expected. I'm using Sonnet here, and I'm passing in the necessary beta headers, not only for skills, but in order for skills to work as expected when talking to the model, I need to make sure I have the code execution beta as well. And since I'm sending a file here, we have to make sure we have the Files API header as well. When working with skills, these skills are set in a keyword argument called container, and here is where I pass in the list of skills. These could be custom ones or built-in ones. As I create many different versions of the skills, I can reference a particular timestamp or just use the latest one that I have. As I start to communicate with the model, I ask it to generate practice questions and then specify the file that I'm working with. This file object was previously created when I uploaded the LaTeX file. We finally make sure we're bringing in the correct tools for code execution and send a message to our API. Now let's go take a look at the response that we got back. We can see here that there are multiple different pieces being used. Tools on the server, code execution, additional tools being used, and then finally a bash code execution result. To make this a little bit cleaner to look at, let's add some nice formatting so that we can go ahead and take a look and analyze different text responses and tool use. We're going to go ahead and see in this particular series what's happening one step at a time. When we take a look at what the response is, which includes our text and our tool use and tool results, the first thing the model is telling us is it can help generate questions from these notes, and it's going to start by reading the skill file and examining the lecture notes. Notice here, it's detected the skill that it needs to use, but it's only reading the skill MD. We're going to see later on if there are additional files that need to be read, we'll make use of that progressive disclosure. We're also going to review in our input that LaTeX file as well. We're going to go ahead and see the underlying data that comes from these files. This is the YAML front matter that we've seen before, as well as the LaTeX from our notes4.tex file. Next, we're going to go ahead and check the Markdown template to use the proper structure, because we want our output to be in Markdown. Here is where we're going to leverage a bit more of that progressive disclosure. Here's where we're going to read inside of the assets folder that Markdown template MD. We'll get back the response that we've read, and now we'll generate the questions based on the lecture notes that we've passed. Here we're going to use our code execution tool to create a particular file. We'll give that file text in Markdown, and we'll get back the result of that file. We're going to go ahead and copy that to an output directory and use our Files API to get back a file ID that we can download later on. Once we get back that result, we can take a look at the underlying file that's been generated and make use of that file ID to programmatically download it. We can see here it's been saved and is ready for use. Using that file ID that we saw above, let's go ahead and download the file. We'll go ahead and check in this response and make sure that we have the file ID correctly extracted. And if we have that, which we expect to do, we should be able to download that particular file. We'll go ahead and write to a file called notes4md with that content. That content includes the file ID, as well as the necessary beta headers to communicate with the API. We can see here, we've downloaded that notes4md file, and this is coming from the Files API with a code execution tool, all generated with the model and a skill. Inside of this file that we've downloaded, we can see that we're following those exact parts that we had in the skill, starting with true and false questions, moving on to explanatory questions, to coding questions, and finally, to use case applications. We can preview this in Markdown to see what that would look like. And here we can see our use case application, all the things necessary. Now's a good time to evaluate this particular output. Did we do exactly what the skill wanted? It looks good to start, but bringing in some unit tests can really take this to the next level. If we need, we can go back and modify the skill, just like we saw before, using the API, the code execution tool, and the files API as well. We also have the ability to delete skills programmatically. In order to delete a skill, we first have to find all of the versions associated with that skill and then delete them. Once those versions are deleted, we should be able to delete the underlying skill right here. Next, we're going to go ahead and use our analyzing time series skill alongside another skill. This is going to look pretty familiar to what we saw above, so let's go through these steps. First, we're going to upload our custom skill, get back a skill ID, and confirm that we've done that as expected. Here, we can also see that we're not loading only the custom skills, we can see the built-in skills as well. These should look pretty familiar, as we saw them as well in Claude AI. Next, we're going to go ahead and upload our input file. This is going to be our retail sales CSV file. We're going to build a message to send to the API. And just like before, we're going to go ahead and use our skill. But here, we're also going to include the doc skill as well. We're going to use this because we want to create a Word doc summarizing the results and the plots. So here, we're seeing a combination of custom skills with the skill ID that we have as well as the version, and using Anthropic built-in skills, in this case, the docx skill. We're passing in the same headers that we had to pass in before, skills, code execution, and the files API. Now that this is finished running, we can examine the particular type of response that we get. We're going to see something similar to what we saw before, but this time there's just a little bit more happening. Let's go and see what's happening under the hood with our nice formatting. So here, the model is going to respond by helping us analyze time series data. And just like before, we're going to start reading the entirety of these skill MD files. We're going to read our custom skill, as well as the built-in docx skill, which we're going to need to use. We can see the result of those include the content starting from the beginning of the file and including the entire skill MD. Next, we're going to go ahead and examine the data to run our time series analysis. We're going to look at just the first 20 lines of this CSV to examine the names of the columns and the type of data that we're working with. Since this is working as expected, we're going to go ahead and run the diagnostics and create the visualizations. These particular commands that we need to run are coming directly from our skill. Here is where we're going to go ahead, read those underlying files, execute that code, and hand that back to Claude to work with. We're going to get back the result of these executions. We're going to get that back for diagnose as well as visualize. We're then going to read the summary and diagnostics, which is the result of our script that comes in a file called summary.txt. Once we have that particular file created, we can then go ahead and create a Word document. The built-in docx skill includes the correct content for how to work with Word docs. We're going to go ahead and take a look at how best to generate that document and leverage progressive disclosure here. We don't need everything from the docx skill, just using a way to get to those markdown files. Once we have that, we'll create the comprehensive Word document using the skill necessary, execute the code to make it do that, and generate the underlying Word document. Once we have that Word document, we'll copy that to the output directory, and just like we saw before, get back a file ID that we can use if we want to download this Word document. We can see a summary of what this data looks like, and now we can download the file. Similarly, we'll go ahead and find that file ID if it exists. We're going to go ahead and download that particular file with the necessary contents as a docx file. If we take a look at what this looks like, we now have a Word document with our findings, our overview, our statistics. We can see that we brought in those plots and visualizations, as well as the statistical analysis that we've requested. This is also a great time to not only evaluate if what we're doing is expected in the skill, but that we're doing this in a predictable fashion. As we continue to evaluate, we can always modify this skill as much as we want. But all this data is coming in from the skill as well as the docx skill to create this individual file. Like we saw before, if we want to delete this skill, we can list all the versions and delete all those versions. And once those versions are deleted, delete the underlying skill. In this lesson, we've combined our knowledge of the Messages API, the Code Execution tool, the Files API, and Skills to take our custom skills and work with them programmatically. In the next lesson, we're going to move to Claude Code and see how to add our own custom skills inside of a .claude folder and build a more sophisticated command line application. We'll now switch to Claude Code and use skills for code generation, reviewing, and testing. We'll also set up subagents and equip them with skills. Let's have some fun. So far, we've seen how to use skills in Claude AI and using the Claude Messages API. Now let's talk about how to use skills in Claude Code in a bit more depth. The application that I'm using is a command line application for creating to-dos that need to be completed and listing them, and eventually editing and clearing. I'm going to show the Claude MD file to give you a sense of what this project does, and then we're going to do a little demo before we jump into each of the individual files. In Claude Code, you have the ability to create a Claude MD file. This file is created using the /init command or manually by the user. This file is always in your context and specific to your project. This is where you can specify general instructions about the code base, project you're working on, technology stack, and things that Claude needs to know in every single conversation. So again, we're building a command line task management application using Python, Typer as our CLI framework, using data classes, rich. We're storing information in a JSON file for persistence, and using UV for dependency management. Our architecture follows according to this pattern. We've got our entry point, and all of our commands get their own individual Python file. We set up our data class in our models.py, our logic for storing, serializing, deserializing in our storage.py, and then to display things nicely in the terminal, our display.py. We have a couple of constants, and then our tests. We can see in this file, we have our priority, our task as data models, how data is persisted. And remember again, for this Claude MD, this is data that is always available in context in every conversation that we have. This is useful information to help Claude figure out where to find things and how best to structure information. So with that in mind, let's hop in and play around with this application. First, I'm going to go ahead and activate the virtual environment. So I'll source, venv, bin, activate. Once I've got that set up, make sure my dependencies are in order with UV sync. And once I've done that, I can actually start using this task command directly in the command line. If I take a look at the command, I see I have commands like add and done and list, as well as some additional options. So let's go ahead and take a look at the tasks that I have right here. Right now, I have none of them that are found. I'll clear the terminal so I can start from the top. And let's go ahead and add a task. Right here, we'll call this write the final report. And we'll give this a priority of high. And we'll give this a date to be done with the following. We can see here I've added that successfully, so let's go take a look. We've got our task right there, our display.py doing some nice formatting of that information. Now let's go ahead and complete it. I'll go ahead and mark that as done with the correct ID. And then if I go ahead and take a look at my list, I can see with that flag that I have this task that is done. The plan for this lesson here is to add another command line command for edit. So we're going to have to go to src, to task, and add another command here for editing. But we also want to make sure that when we add these additional commands, we're following the correct workflow. We're following a proper way of adding commands the right way to pattern match a bit of what we've done in this code base. In order to do so, we're going to be using a skill here that we've added called adding CLI command. Skills are defined inside of the .claude folder, followed by a folder called skills. When we take a look at this skill, first, not only we can see that this is available at the project level, we can also create skills at the user level in our home directory if we'd like as well. For this example, we'll be focusing in project-specific skills. So let's dive into what's happening for this particular skill. Just like we saw before, we have a name and a description. And here, we're going to really lean into the particular coding styles and functionality that we want when creating new commands. We're going to start by identifying the workflow necessary and creating files in the appropriate directories. Just like we have commands for add and done and list, we want to make sure that when we make new files for commands, it lives there. We also want to make sure that these commands are registered in our dunder-init.py file that lives in the command folder. When we think about how to create different commands, there may be lots of different kinds. There may be commands that involve subcommands or flags or additional arguments. You can provide plain text instructions to Claude, but especially for coding examples, Claude does really well when you tell it exactly what pattern and style you want to follow. In the typer library, there are many different ways of accomplishing particular tasks. For example, there are many different ways of adding type annotations to arguments that are being decorated. In this particular case, this is the convention we want to follow, as it's a little bit more modern. You can imagine in libraries and code bases that you use, there are many different ways of doing things. But what's useful about skills is it gives us that predictable workflow for a set of tasks. We also want to make sure we're using this display object here and calling methods like success and info to make sure that when we add a command, we're not only executing the business logic, but displaying the correct information to the user at the end. When we work with flags, we want particular shorthand, we want particular longer ways of addressing it. We want to make sure that there's help text as well. All of these pieces, type annotations, default arguments, certain return values, are valuable to add in your skill so that you know how best to pattern match and follow predictable workflows. As we think about commands with subcommands, not only can you see here how we want to structure individual commands, but also how we want to display when things like migrations or versions are changed. As we imagine commands that might be destructive, as we start adding functionality to clear, we might want to specify what kind of delete we're doing. If we choose to do a hard delete, we want to make sure that we confirm before we go ahead and delete that particular task. This pattern can be followed as Claude starts to see additional commands that might need to involve some kind of deletion. As we think about registering, we want to be intentional about how to add single commands and command groups. So not only are we giving Claude instructions for how to register commands, we're being very specific with what conventions to follow. And finally, as we talk about conventions, here's where we can lean into requirements on our docstrings, being mindful of exit codes and following constants that we have, being mindful of commands that are destructive. This is a really useful place so that when we build our predictable workflows, we know exactly what conventions we're following. These are not conventions that have to exist everywhere in the code base and have to be loaded everywhere in context. If so, we could put them in the Claude MD. But in this case, just for adding individual commands, there's a subset of conventions to follow. Let's only load those when necessary. And not only are we using generic naming like CLI app, we can use this skill across any platform that follows the agent skills convention. And depending on whatever CLI you're building, if you want Claude to follow these particular patterns, this skill can easily be adapted to do that. Now that we have a skill for adding CLI commands, let's also make sure that when we start to do this particular workflow of adding commands, we're being mindful of testing and also validating the commands that we write. This is another great use case for another skill. In our second skill, for generating CLI tests, we generate PyTest tests for typer commands. We include here what kinds of fixtures we want, how to handle edge cases, and this is really important that we add what to do and how to trigger this particular skill. You can see here, use when the user asks to write tests, test for my CLI, or add test coverage. It's always important to be very explicit not only in what the description is, but how Claude can detect how to run it. Similar to other skills, we specify the workflow that we want. When writing tests, it's often best practice to leverage fixtures. You can think of fixtures as information that is run each time as you arrange your tests to set up information, to set up dummy data, as well as any kind of mocking or test infrastructure that you need for each of the tests that you write. For example, here, we specify what our temporary storage might look like, and we specify what some sample data might look like. As we run each of these tests, this information will be exposed to allow us to arrange and set up the tests necessary when we test individual files, folders, and workflows. As we take a look at the test structure, we're following a pattern of arranging, like we mentioned with our fixtures, invoking some kind of action, and then asserting that the result is the case. Right here, we're simply trying to build patterns that Claude can use and follow when this skill is leveraged. We can continue on with how we want this test runner to be done and how to test scenarios by a command type. As we read, as we add, here are examples for what we want our tests to look like. As with many testing libraries, there are lots of ways to accomplish a similar kind of task. For these examples, here's the pattern we want to follow. As we wrap towards the end of this skill, we want to think a little bit about edge cases to cover. When writing tests, we want to think about invalid input, any kind of state, confirmation, or what happens when things are not found or don't exist. We want to make sure that we're following a checklist as well when we go ahead and write our tests. And then finally, to make sure we're running tests correctly, providing the correct commands, as well as how to run in a verbose mode and for specific files. The last skill that we have here is to wrap up and review and make sure that we're executing the commands as expected. Once we've generated the tests and the tests are running, let's make sure we're following the correct conventions. Just like we saw with other skills, there are ways in which we can execute the task necessary and then come back and validate that things are working as expected. As we think about reviewing these commands, not only do we think about the underlying structure, is this in the right location? Is this using the right decorator? Is this registered correctly? But we're also making sure that some of those practices we wanted around type annotations or options for parameters or flags when possible always are included. It's often helpful to provide positive and negative examples. So as we mentioned, using this annotated type versus a different kind of way to type your arguments. As we think more about error handling and output, we make sure that this checklist exists so that the skill can go through and confirm that all of these pieces are as expected. We're not telling Claude how to perform these actions like adding commands and generating tests. We're making sure that it's working as expected. You can think of this like an evaluation almost for the other skills that we have, and including this skill as part of our workflow. As we take a look at the bottom, making sure that our best practices are followed, as well as examples of mistakes we might see and fixes for those. As we take a look at the output format of this skill, we want to make sure that all of our checklist is addressed, including a summary and suggested fixes. It's very useful to have this underlying review so that when features are finished, we can start by taking a look at this review, include this even as part of our code review, and make sure we're building production-grade features backed by tests following best practices. With that in mind, let's start to put all of these skills together. The first thing we're going to do here is to add a new command that allows us to edit individual tasks. We're going to want to make sure we edit the title and priority and pass in an ID that is valid. Now let's hop into Claude Code and use these skills. To make sure that I've registered these correctly, I'm first going to just type in /skills. This is going to list the available skills that I have to me. These are project skills. We also mentioned we can add skills in our home directory, but right now we're just dealing with project skills. We can also see the amount of tokens that these skills are taking as we just think about the name and description necessary. When you create a new skill in Claude Code, you want to make sure that you close Claude Code and open it up again so that skill can be identified. So if you find yourself looking at your list of skills, but you're missing the one that you might have just created, make sure to close that instance of Claude Code, open it up again, and you should be in good shape. Now that our skills are loaded correctly, let's go ahead and add a new edit command to allow users to edit the title and priority. We're adding a little example here and ensuring that we follow the conventions for creating a new CLI command. So let's give this a shot. We can see here that Claude Code is prompting to use the adding CLI command skill, and that's great. We'll go ahead and make sure that in the future, it doesn't prompt us to do so. We can see here we're going to read the existing files and storage to understand the convention, as well as take a look at examples of other commands for reference. Now that we know the conventions, let's go ahead and create that particular file. We can see here there's a new file edit.py being created, and we're going to go ahead and make that change. We'll see here edit.py appears, and we're now going to register that command, following the order that the skill has set out for us. We can see here that the command is being registered inside of our dunder init as expected. We're going to go ahead and make that change as well. So we'll go ahead and let it proceed and run this command to test out and make sure it's working as expected. Looks like we're seeing what we expect, and that's in good shape. It's now going to run the add command and then go ahead and run the list to make sure we've added successfully. It's seeding some data that we can then make sure the edit command works as expected. We'll go ahead and edit that particular task, and we'll see here that we didn't specify a title or priority. We'll then go ahead and put in that title, and here we'll see that edited as expected. It's going to ask me again to edit this task, and this is going to happen over and over as we start to test all kinds of examples. And while I could proceed over and over again, we can imagine that this might start to fill up the context window quite a bit. And if this were a larger scale system, might be very time intensive and even compute intensive. So what we're going to do here is something slightly different. We're going to leverage the functionality that Claude Code has for using subagents. We're going to have one subagent to review code and follow the criteria so that the main agent can focus on the development. We're then going to have another subagent to generate and run the tests using the skill that we have. What's going to be useful about this is that we can have the main agent focus on development, while subagents in their own context window focus on generating the tests and reviewing the code. We can then take the feedback and tests generated, bring it back to the main agent with a much more context-efficient approach. It's important to note that subagents do not inherit skills from a parent, so we need to be explicit with the skills that we give to each subagent that we make. There are multiple ways of passing skills to subagents. One way we're going to show you is being explicit with the name of the skill in the subagent. Another option that we'll link in the notes is where you can provide the exact agent name and how best to run it from the skill directly. With that in mind, let's go ahead and create our subagents. The first agent we're going to make is our code reviewer, and we're going to create these agents using the /agents command. We're going to create a new agent. We're going to do that on a project basis, but instead of generating with Claude, we're going to follow a manual configuration so you can see what it looks like to add a name, description, tools, and most importantly, skills for each of our agents. The first one I'll make we'll call code reviewer. This will be the unique identifier for our agent, and then we'll pass a prompt to it. We're going to paste in a prompt that we'll take a look at once we've created this, but is going to look very familiar to how we review and how we're specific and actionable in the insights we make when doing the code review. We're going to go ahead and give this agent a description for when it should go ahead and be used. We're going to review for code quality, security, and so on. We're going to try to make this agent as generic as possible. For the set of tools that we want here, we want to be very specific with the tools that our subagent has access to. So we'll make sure that if there's code that needs to be executed, we give it bash, glob and grep for finding files, and read to read underlying files that we're going to be reviewing. Once we've selected these tools, we can go ahead and continue. We'll decide to inherit from the parent with the model that we use, and we'll go ahead and give this a color of purple. Once we've got this set up, we'll go ahead and save this agent. We can see here now in our agents folder that we have a code reviewer agent to work with. We've got the code reviewer, a description, tools, and all of the wonderful pieces that we added. It's now time to make sure we specify the skills that we want this subagent to use. We'll do that using the skills field and specify the name of the skill that we're working with. In our case, reviewing CLI command. Before we create our next agent, let's do a quick review of what we made here. Our agent has a name and description, tools available, a model that we inherit, a color, and skills that we brought in. We can add multiple skills, but right now we're going to stick with one. In our prompt, we mention it's a code reviewer, ensuring high standards. As we specify what this agent is, we specify when it's invoked, general quality checks, if we're working with Python, how to be intentional, CLI commands the same way, and a particular output format. Like we mentioned, this agent is a bit more generic. And while we're using it in the context of our specific application, skills can help us be more particular. But this agent might need to be used across a different variety of applications, so we want to be a little bit more generic with what we're trying to do here. It's important to note that skills operate slightly differently as subagents in Claude Code. When this subagent is dispatched and created, the skill is not only loading the name and description, but the entire skill MD. These skills are preloaded when the agent is dispatched. If there is additional progressive disclosure, reading of other files or other commands, that is not done, but the entire skill MD is read when the subagent is dispatched. Now that we've got our code reviewer agent, let's add another agent for generating and running our tests. Let's go ahead and make our second agent. We're going to go create a new agent in our project using the manual configuration, and we'll call that test generator runner. We're going to go ahead and add a prompt here that we'll review a little bit later, but it's going to follow similar patterns to what we saw with the other agent that we made. We'll go ahead and specify a description for this agent where we'll specify that it should run tests and generate them if missing. When the user asks to test or run tests, let's go ahead and make sure that this agent is dispatched. Like we saw before, instead of giving access to all tools, let's go to our advanced options. In our advanced options, we're going to go ahead and disable all of our tools. And here, we'll make sure we have a bash tool, glob and grep, read as well. But we're also going to need to edit and write individual files, and in our case, edit files that may already exist. Once we've got these tools set up, let's move on, talk a little bit about the model we're going to be using. Just like before, we'll inherit from the parent, and we'll go ahead and use yellow for this subagent. This looks good to us, so we'll go ahead and save it. Once we've created this agent, we also want to make sure we specify what skills are being used. In this case, the skills that we're going to be using is the generating CLI tests skill. Again, we could add multiple skills, but in this case, we're just going to use that individual one. As we saw before, we specify when it's invoked, we show how to discover tests and the output format that we want, and then some underlying rules to make sure that things are working as expected, and just like our other agent, to be a little bit more generic and lean on skills to provide consistent workflows. Now that we've created our subagents and our skills, let's put this all together to make sure that when we add new commands, we dispatch subagents when necessary using the skills that we want. Let's go ahead and start by using our code reviewer subagent to review the edit py command that we made. This should not only dispatch the subagent, but also make use of the skill that we provided to that subagent. We're going to see here that the code reviewer agent has been dispatched. And now we're going to go ahead and use the necessary skills and tools that we've defined. We can see here what's working and what's not working. No critical results, but we've got some warnings, issues to fix, and suggested fixes. We can go ahead and use the main agent to implement those if we'd like. We're then going to use our test runner subagent to generate the tests for our edit.py command. So we'll go ahead and make sure that we're referencing the edit.py file and go ahead and dispatch the second subagent. We can see here it's generated the necessary commands, and it's prompting me to make sure that we want to make this edit. So we'll go ahead and do so as we add tests for editing. I can confirm that the tests are working using this command uv-run, and then we'll go ahead and run all of our tests with verbose mode to make sure things are passing and there are no regressions. Once this is done, we can see that all of our tests are passing, none are failing, and here's a summary as well. We made use of two different subagents leveraging multiple skills, and as we start to add more features and functionality, we can put these all together. The next thing we're going to do is see our code reviewer subagent and our test runner subagent in action. Let's imagine there's a clear.py file, a new command that's been added by someone on the team who hasn't followed best practices and maybe didn't use all the skills and infrastructure that we set up. We're going to go ahead and use our code reviewer subagent as well as our test runner subagent to figure out how best to fix the clear.py file. We're going to dispatch our code reviewer to review the clear.py command, and then we're going to use our test generator runner to generate the test necessary for this command. We'll validate finally that things are working as expected and make sure all the tests are passing and following the best practices that we've standardized. We can see here there are quite a few issues and some warnings. Now that we've found these issues, let's make sure that the main agent is reading the files and fixing them. We're going to want to make sure that we allow for these edits to clear.py. And here we can see things like displaying things to the console are done using the correct methods like display, as mentioned in our best practices. We also want to make sure that we're registering this command correctly inside of our dunder init. The main agent itself is not adding additional context for the reviewing and generating tests. It's simply taking the output of the subagent to better execute these tasks. Next up, it's time to generate tests for the clear command that is following our best practices. We can see here it's adding a file to test this clear command. Let's go ahead and approve that. Now that we've created this file, let's go ahead and run the tests, make sure they're working as expected. And now we can get a summary of what's been completed. 6 critical issues, 4 warnings, and all of them fixed. Instead of using incorrect methods, instead of using flags that are not the right format that we want, incorrect exit codes, we fixed quite a few different issues. We've then added tests on top of that to make sure that we're confirming that all these best practices are done as expected and the functionality is working that we'd like. In the next lesson, we'll shift away from Claude Code and move to the Claude Agent SDK and showcase how to use skills when building your own agents using the same harness that Claude Code uses. In this final lesson, we'll create a research agent using the Claude Agent SDK. The agent will use a skill to create a learning guide for an open source tool based on its documentation, GitHub repo, and web search. Let's go. Now that we've seen how to use skills on the web with Claude, using the Messages API and Claude Code, let's talk about how to use skills with the Claude Agent SDK. As a refresher, the Claude Agent SDK is a programmatic way of building your own agentic applications that use the same internal harness that Claude Code does. What we're going to be building here is a general purpose research agent. The main agent is going to be able to research information from multiple sources and synthesize a summary. It will dispatch 3 different subagents for analyzing documentation, analyzing and downloading repositories, and researching information by searching the web. Let's take a look at those prompts, and then we'll take a look at a skill that's used to guide the main agent with the research methodology and what needs to be extracted and synthesized. To start, we have our main agent prompt. This is the orchestrator that has access to 3 available subagents with the following capabilities: finding information from documentation, analyzing repository structures, finding articles, videos, and community content to bring it all together. In this particular application, we mention that if the skill is provided, we want it to follow a particular pattern. It's possible that skills may or may not be provided for the application we're building, but in our case, we're going to provide one. If the skill matches the user's request, we need to follow that skill's instructions precisely. Since we're starting from scratch with this agentic application, we want to be very intentional about what to do when skills are provided or when they're not. As we continue, we have a couple high-level delegation guidelines for how to spawn subagents, and after receiving results, how to synthesize all of those pieces of information. Let's briefly dive into some of the prompts for our subagents. For the documentation researcher, we'll have access to web search and web fetch. We provide a process to locate documentation, particular input formats, guidelines, and an output to return findings in a certain way. For the repository analyzer, we also provide web search to find repositories, bash commands to clone and run Git, and then the ability to read and find files and data within files. Similarly, we provide a process, an input format, guidelines, and an output. Finally, our web researcher makes use of web search and web fetch as well. This allows us to search for content relevant to that topic and to receive extraction instructions as well from the main agent. We also provide guidelines as well as an output format that's necessary, and if no output format is specified, follow a default structure. All of these prompts will be used together when we set up the code necessary to make our agent work. Finally, let's talk about the skill we're going to be using here. We have a skill named Learning a Tool. The purpose of this skill here is to guide the main orchestrator. We will not be using this skill in our individual subagents, but we're using this skill as a way to create a predictable pattern so that the main agent knows the ideal workflow and what and how to dispatch subagents. We give the skill a name and a description, and in this case, we want to create learning paths for programming tools to find what information should be researched and specify how best to follow an approach to researching all the way towards creating a comprehensive learning path. To start, we have a very particular workflow that we have here. We start with a research phase, and we specify for official documentation for that subagent exactly what to look for. For the repository analyzer, a similar kind of approach, and for our web researcher, very similar as well. So we're using this skill to provide a constant and predictable workflow for how best to work alongside the subagents that the main agent has. Once that data is given to us, we then organize that content into progressive levels. Here, we're using progressive disclosure to lean into loading another markdown file as the source of truth. In our progressive learning file, we can see there's quite a bit around the individual levels that we want, starting from an overview and motivation, all the way towards installing core concepts, practical patterns, and then where to go next. This progressive learning allows us to build levels so that we know how to start from the beginning and know eventually where to go deeper. While this initial skill is useful for learning a tool, you can also imagine that we might have additional skills for maybe comparing one tool with another depending on the data that we're working with. As we move towards the additional phases of working with this skill, we take that data and specify a structure and then specify an output. We're very, very particular with the exact format that we're working with. The goal here is to get access to a learning environment that gives us an overview, resources, a path, and code examples. The goal here is to combine the research from all of our subagents into a particular output format that we want, and do that with consistency and predictability. Now that we've seen at a high level of the application we're going to build, there's one last piece that we'll layer on. We can imagine that we want to take the output and write it to a centralized place that we can share with teammates that might have a nicer interface. And to do that, we're going to use Notion. To connect to Notion, we're going to use an MCP server and bring in the tools necessary to go ahead and execute that. Now that we've examined the underlying prompts for our main agent and subagents, as well as the skill we're going to be using, let's go ahead and begin by running UV init and initialize a project and add the necessary dependencies like Claude Agent SDK, python.env, and async.io. Once we've installed these dependencies, let's go ahead and create a file called agent.py. So I'll go ahead, make a new file, call that agent.py. Inside of our agent.py, I'm going to be adding the necessary code to just get started with a small example using the Claude Agent SDK. The boilerplate here brings in async.io to run this environment, .env to load environment variables, and then from our utils, the display message function. Just to give some context, display message gives us a bunch of helpers for truncating and formatting input, and it gives us a nice way to visually display information from the main agent and the subagent. This is very similar code to what we saw when we worked with the API, and we got that nice output for what's happening in each tool action and iteration. To start, we set up our Claude agent. We pass in a system prompt here. This is going to change. We pass in allowed tools. This is also going to change, but we just want to start with the basics here. To get started with a simple conversation, we set up a loop, accept some user input, run that through our model, and take back the response and send that back to the user. Let's go and see what that looks like. I'm going to open the terminal again, and we're going to go ahead and run uv run agent.py. This is going to provide a terminal environment to us where we can start a conversation. I'll just start by asking, how are you? In this case, I'm not going to get a ton of valuable information here because I just have a helpful assistant. So what we're going to start layering on now is the ability for our agent to get access to MCP servers and the correct tools as well. Let's go ahead and make some modifications to our main function. Like we mentioned, the allowed tools are going to change. So what we're going to start doing is adding the tools that our subagents need to use so that they can be working as expected. Read-only tools like read and grep and glob are allowed by default, but when we want to start doing things like writing files, searching the web, and executing commands by bash, we need to pass that in explicitly. So we'll bring in the write tool, the bash tool, and our web search and web fetch tools. We saw previously that our subagents are going to be making use of these particular tools. Our agent that's analyzing repositories needs bash to run git commands and writing files, and our docs researcher and web researcher will make use of searching and fetching. Now that we brought in these tools, the next thing we're going to add are MCP servers to connect to. We'll use the MCP servers keyword argument and specify the name of the MCP server, which in our case is Notion. We're going to pass in some default configuration, and we're going to specify the command to run the Notion server alongside a Notion environment variable that we have. So we're going to make sure before we go ahead from our .env file, load in our Notion token, and import the OS module to make sure that we can read that file correctly. Now that we've loaded our MCP server correctly, we need to make use of the tools that Notion provides. If we would like, we can ask Claude right now, what are all the tools that you get from this MCP server? Or we can go ahead and add those explicitly by using MCP, the name of our server, followed by the name of the tool. In this case, we're going to be using all of the tools that Notion provides to us. We need to make sure that this MCP Notion exists in allowed tools so that we can give the main agent permission to use this set of tools. We can explicitly add the name of the tool, or in our case, we're just going to include all the tools available that MCP Notion provides to us. Now that we've set up our MCP servers and our allowed tools, let's go ahead and bring in our subagents and definitions for them. We mentioned that our system prompt is going to change. And to start, we're going to go ahead and load all of the prompts that we have. We'll bring in a constant and a helper function that we have to to load all of these prompts, we're going to go ahead and call that function to go ahead and bring in these prompts inside of our main function. We're going to make use of these markdown files to load in the text necessary and pass them to our agent options. Before we go ahead and update the main agent, we're going to add a dictionary that references all of our agents with a definition. We're bringing in the agent definition class, which we'll want to make sure we import correctly. We can see in the agent definition, we have a description for our subagent, a prompt that specifies the instructions for the agent, and then the tools that we want that agent to use. Similar configuration to what we did in Claude Code. You can see here, we still need to use our main agent prompt as well as this dictionary of agents. So we'll update our system prompt with the main agent prompt, and then we'll make sure to pass in an additional keyword argument of agents that references our dictionary with our agent definitions. As you can see here, our researcher, our analyzer, and our web researcher are using tools that we've defined here as well. It's important to make sure that you list all of the tools that your main agent and your subagents will need to use inside of your allowed tools, or else your subagents will not allow them, even if you include the tools here. Now that we've set up our agents, we need to make sure we also include the all-important task tool to make sure that we can dispatch subagents and assign tasks to them. The last piece we need to add here are skills. And the good news is, in order to add skills, there's just one more tool that we need to add, and that is the skill tool. Since we have an environment here where there's a file system and the ability to execute code using the bash tool, all we need to add is this skill tool so that we can correctly read skills and understand how best to use them. Similar to Claude Code, skills are defined inside of a .claude folder, followed by a folder called skills. Make sure your markdown files are skill.md and your folder is called skills in the plural. Now that we've added the tool for working with skills, there's one more keyword argument that we need to pass in here. We need to specify where we find this particular set of skills. And we do so with a keyword argument called setting sources. And here we're going to specify that we want to find skills inside of the user directory, if we have skills in our home directory, as well as project, which is where we've loaded the skills for this particular application. Now that we put this all together, let's go ahead and test out our agent. I'm going to open up the terminal again. I'm going to go ahead and exit, and let's run this application again with the changes that we've made. We're going to start by learning a little bit about MinerU. For those of you not familiar, MinerU is an open library for PDF extraction. And the reason we're using this example is because this is not something that Claude might know a ton of from its initial training data. This is going to require external research, analyzing code repositories, community documents, and other sources. We're going to ask to create a learning guide and then show me the plan first. Here, we're going to start to see that the skill is invoked, and the input here is that skill called learning a tool with the arguments that we specified. So here we can see that we first specified the plan. We still have to go ahead and run what the subagents are going to do, but just like with Claude Code and plan mode, we might want to see what the plan is before we start acting and consuming tokens and taking time. We can see the research phase of parallel investigation with our different researchers. We can see the structure necessary according to the skill, and then finally, the output that we're expecting. This looks like a good plan, so we'll just go ahead and ask it to proceed. It's going to start by spawning the docs research subagent, spawning the repo analyzer and web researcher, and executing these in parallel, using the tools that we've added under the allowed tools that we've also passed in to our subagents. We can see in parallel, the docs researcher is heading to the documentation, the repo analyzer is looking on GitHub, and the web researcher is searching across tutorials and YouTube guides. We're extracting the information from GitHub repositories using the bash commands, while at the same time, searching a YouTube channel for video demonstrations. These agents are interacting in parallel, fetching from different data sources to bring this all together into a compelling tutorial. Now that the subagents have finished completing their work, we're going to create the comprehensive guide, pull together all the necessary files based on this research that we have here. As instructed in the repository analyzer, we've cloned the repository for MinerU, and keeping that here, and we've started to build the folder structure for learning this. We can see here, we have our README and resources, as well as code examples that are being put together. We can see here in the README file it provides the learning path to us, what we're going to learn, how to use this guide, and importantly, time estimates that we might need. We can see here it's created for us the README, the resources, and the learning path is still in progress. Inside of our resources, we have links and references for mine or you. So let's take a look at that. Inside of our resources, we have documentation, the repository, PyPy package, and the paper underlying this library. We have quick start guides, documentation, and related projects. As we pull in additional information from the community, we have all kinds of deep dives across a variety of different articles and news coverage. Now we can see that the learning path has been created, and it's time to create the code examples. Let's take a look at this learning path. Starting with an overview and motivation, what problem does it solve? We describe the origin story of the library, what existed before, and some of the problems with those libraries. We can see here this is quite an in-depth guide and learning path, and you can imagine this is something that would last a long time as you start to get up to speed, knowing very little, to becoming an expert in working with this library. We move into some of the distinct features of the back end of this library, all the way to code examples, and many different characteristics for how to use this as efficiently as possible. We can start to see that our code files are being written for Hello World examples, concepts, and patterns. For our Hello World example, we've got a nice README to get started with some first steps, simple extraction to see how to start using this library, as well as installation steps. If there were particular libraries we wanted to use for installing or patterns here, we could always add that to our skill. But right now, this is going to give us a great start to get up and running with this library. As we look at some of the core concepts, those are being created currently. Now that those are done, we can see in the README where we go next. Once we've gotten up and running with the library, we can start to look at some of the fundamental concepts that the library possesses, as well as comparing different speeds across backends. Finally, we're going to create practical patterns and examples with this third folder. We can take a look at this folder, and we can see here that we have real-world processing pipelines and production use cases. This includes examples for certain patterns, as well as quite in-depth code examples using this library with doc strings, comments, and everything necessary to use this library to its fullest extent. We'll wrap up by validating and creating a summary document and making sure everything has been done correctly. We can take a look at the output, which gives us a complete learning guide, the directory structure as specified in our skill, the learning path with the levels that we requested, and then key features and a quick start to get up and running. The final thing we're going to do here is write this particular file, the resources MD, to a resources subpage in Notion. This page already exists, so let's take a look at what that looks like, and then we'll prompt to go ahead and use our MCP server to do the writing necessary. We can see here in Notion, under this learning section, I have a subpage called resources. The goal here is to use the MCP server to populate what we had in our resources MD to this right here. So let's go ahead and ask our agent to write that file to that subpage in Notion. We're going to be explicit with the tools that we use in Notion and allow it to use what we have available. We found the resources page. We're going to read the resources MD and convert it to the correct format in Notion using rich Notion blocks. You can see here we're using multiple tools from Notion, doing this in batches, adding the quick start guides, API documentation, and the rest of the information inside of our resources MD. We can see here in the resources file, it's dynamically updating based on the documentation in our resources MD. And as this finishes up, we're going to see all the content from that file appear on our Notion page. Now that it's finished, let's go take a look at what our Notion page looks like. We can see here, we've got our official documentation, our tutorials, video resources, community channels, all the data that came from that markdown file, we've now written to Notion. We've made use of skills, MCP servers, agents, and subagents all using the agent SDK. You can imagine layering on additional skills for a more complex workflow, or additional subagents to perform a variety of tasks. We've just started to scratch the surface with functionality, and there's still some security concerns that we should be mindful of. For starters, we're allowing commands like write and bash to be executed without requiring permission from the user. The next step here is to build an interface, just like Claude Code, that ensures that we allow the user to confirm that they want to use those particular tools for a certain action. We've also just started to scratch the surface with the ability to even add things like interrupts for our agents and subagents, similar to Claude Code. So we've given you the foundation, to continue to build powerful agentic applications, and we can't wait to see what you build next. Congratulations on making it this far. You've learned how to create skills, explored their best practices, and seen them in action across different platforms. When creating a skill, start with basic Markdown instructions, then expand later following progressive disclosure. Monitor how your agent uses your skill in real scenarios and iterate based on observations. Make sure the description contains enough detail for your agent to know when to use it. Don't forget, Claude is very knowledgeable about what skills are, so you can always start with a simple conversation to begin creating skills, and then use the skill creator skill to follow best practices. Thank you for joining me in this journey, and I can't wait to see what you build with agent skills.